Out is live. So today is Thursday, October 16th, 2014, 11 a.m. Pacific, and this is DB Hangouts. And today we're going to be talking about what graphs make a good dashboard in MySQL, and soliciting some just kind of feedback and general Q&A around MySQL SYS. So let's get started with a quick round of introductions. I'm Jeffrey Anderson. I'm a DBA at Box. Go ahead, Jerry.
I'm Jerry Narvaja. I'm Senior Sales Engineering at MariaDB Corporation.
Okay, Jeremy.
Jeremy Tinley, Senior DBA at Etsy.
And Mark.
Hey, I'm Mark Beef. I'm a development manager with MySQL Developer.
Okay, cool. So yeah, this was a topic that Jeremy had actually asked about a couple months ago now, I think. Just what graphs do people use to make their dashboards? How do you help triage your live issues? What kind of things do you use to measure your health and capacity? And so actually, Jeremy, if you want to get us kicked off, and maybe hopefully more people will join up as we're going.
I would love to. So graphs. The reason I brought this one up is I have a kind of a big love for graphs. I think that they give you a real general picture. Sometimes it can be better to see trends than just looking at raw numbers. So my kind of general background in this one is what Etsy does for some of our graphs. So we'll talk about from mine. Let me share my screen and I can show what we're doing. And hopefully that's sharing correctly. So we've got a couple of different places we do graphs. Our background for graphs is Ganglia and Graphite. Ganglia is a good drop-in for us. We've got some collectors that will go out and collect all the useful NODB numbers and status variables and all that kind of stuff and stick them in there. And then we use Graphite for a couple of one-off pieces of data where we want to see different aggregates and such. So from our point of view, I'll show we have a couple of different dashboards that from the MySQL team we kind of care about. We have probably 300 or 400 different dashboards, and each one of them has anywhere from 20 to 30 graphs on them. So kind of focusing on the MySQL ones. We do a deploy dashboard. At Etsy, we deploy anywhere from 20 to 60 times a day code to the main site. And so a lot of those are kind of reactionary things where after you push, you want to make sure that you didn't negatively impact. So we have some graphs for showing like aggregate CPU, I/O wait, MySQL connections. We also do a similar one with like replication lag. We've got a small spike here of 26 seconds on one of our servers. Sleeping connections, and then CPU system. And these are stacked graphs that show basically all of our sharded capacity and kind of give us ideas when we see some increase in utilization. From there, we have, when we do schema changes, we show something similar to this. This is paired cluster, similar graphs for sharded environments and basically for everything. But we also want to see replication lag, I/O wait, and then our queries per second, so that we're able to see if we pull aside that our traffic did indeed drop off. And then we have a Ajax-y chart here that shows basically the host names, the replication lag, total connections, running connections, and then connection delta since the last pull, which would be 2 seconds ago. So we're churning out 3,400 connections every 2 seconds on these, and that's really useful for us being able to tell that we've actually tapered that traffic off. In order to know that we can go ahead and successfully apply like a schema update. So then we have in Ganglia, and it's a little difficult to get all these blurred out, but we have basically lists of graphs that show certain values. And so what I couldn't quite capture in this graph was at the top we have a pull down that allows us to change what metrics we see from Ganglia, and then these graphs will represent our A sides and our B sides going all the way down. We also plot things like chef deploys with these lines. These get additional information for things like network deploys, configuration, web stack deploys. For us, we care mostly about the chef ones because those might have a potential for impact. So this one's representing MySQL connections of how many connections we're taking per polling period. But we do try to, these actually have, we've got ones for queries for insert, update, select, deletes. We've got another one for partitions used, basically any value we pull out of it, NODB buffer pool, mutex weights, all this kind of fun stuff. The last one I was going to show is one we're actually putting together in Graphite right now, which is Percona 5.5 and 5.6 have the query response time buckets. So we started pulling that data and sticking it inside of Graphite, and this was to give us some good ideas of what buckets do our query response times fit into, and hopefully these actually start from fastest bucket and go to the longest bucket. And so the more we see on the lower end, the happier we are in general. Unfortunately, we don't have anything to display in the super fast, but we get down into the 0.1 millisecond and the 1 millisecond range reasonably well here for our workloads. That's really what we cover. From a general dashboard standpoint, we look at overall health of the cluster as far as queries per second, and then the differences between the amount of read and write traffic that we do. And then for any specific incidents that we have, we can go look at individual graphs and trends and that kind of stuff to know where we are.
Cool. And is all that stuff just using all the collectors that are available for Ganglia under Etsy's GitHub, or do you guys have some other custom stuff that you've put together that isn't easy to share?
Yeah, the Ganglia collectors for all the stock system information are all just stock Ganglia. We do a cron 1 minute rolling capture of like a directory that pulls all the extra stuff. I can't remember exactly where our MySQL collector is. We've modified it a little bit, but it was basically an open source one. So I'll grab the link and throw it inside of our chat for later.
Cool. So yeah, we had a few late additions. It looks like John and Morgan jumped in. And so just so you guys know, what we're talking about are what graphs make a good dashboard. And if you guys have anything you want to share that you have probably scrubbed before you put it on the screen, feel free to jump in. If not, I've got a few I can do.
I don't have any pictures, but I do have a lot to say about graphing. So.
Oh, okay. Well, let me do some pictures first, then, and then I'll let you jump in. So let me go ahead and grab the screen share real quick. All right. Yeah. So this is at Box we built a tool called Status Wolf, which interfaces currently with OpenTSDB predominantly. But I think it's being refactored so it can talk to more metric backends. But one of the best things this gives us is easy week-over-week information of all of our TSDB metrics. And so we actually, for a lot of our top-level clusters, we plug them in here. And the big things we want to look at are, week-over-week, what are the QPS and CPU looking like? Because these are usually the most indicative of a significant change. And so actually, you can see right now, our QPS and CPU is actually down a little bit than where it was last week. We've actually been doing a lot of optimizations over the past week to improve some of the performance of our stuff that we have. Since this isn't the live Status Wolf UI, I can't show you guys around too much, but you can click on the various dialogues here, bring up other graphs and stuff, and you can there's a search UI to bring them up. My team personally doesn't usually click around in this interface. We actually talk to our Hubot instance that we have running and just ask it for the graph for a given cluster or set of servers to get this kind of information. So Status Wolf aside, when we have to do a lot of the on-the-fly plotting, we usually just kind of fall back to the TSDB interface that is a little fugly but works well enough for what we're doing. And so this is one of the more interesting metrics we have. And so Jeremy, you were talking about how you have kind of the response time stuff. Well, this is our metric for that information. And we typically look at this per cluster to see is the query response time going up or down over week over week or something like that. And so again, I had to scrub a lot of the data out, but we actually had a change that we merged recently where we moved a pretty contentious table out of one of our busier clusters, and so we actually saw query response time come down shortly after that and be a little more, it'll be less spiky. Another one that we recently put in is stuff that is pulling out of performance schema. So this is one Gavin had actually got put together, the collectors for this. So we have 5.6 live on one of our clusters right now in production. and we're working on upgrading a lot of the other ones. And so in the meantime, we wanted to start pulling all the information about threads and just kind of weights that happen inside of MySQL 5.6. And so Gavin wrote a quick collector that queries performance schema periodically and dumps the information into these high-level metrics. And so we can plug in different thread names that show up in the performance schema tables to look at what they're doing. And so this is just an example of the InnoDB purge thread that's running on one of our active masters. And you can see this kind of very interval kind of purging happening. Another one that has become super useful in debugging our live issues is rows read and rows changed. And that the graph I showed earlier with our kind of query response time going down, this is actually showing the cutover of the read traffic from one cluster to another. And so you can see we eventually moved reads coming off of one cluster, so that went to 0, and the other one ramped up shortly after. But what we found recently is, the problems that we have with MySQL, historically you'd be able to run a show process list a few times and kind of see a common pattern or a bad query and just chase it down. But more and more recently, since our query performance has gotten so good, we have things that are just kind of flooding in quicker, and we needed a really fast way to kind of drill down on them. And so being able to look at rows read and rows changed for specific tables on a given schema or a given instance allows us to see, is there a hot shard? Is there a hot table, particularly during certain times of the day? Do we have a cron job that's doing a lot of nasty work at some point? And so this has been the easiest way. Like, this is just showing, a traffic change as we shifted a table from one master to another. But for other situations, we can plot, you could see like a massive spike on rows read from a specific table, and then okay, maybe there's some really weird edge case that's happening with that. Replication information, as Jeremy said, we just grab everything in show slave status and dump that into a metric in TSDB. So we can plot that for every cluster we have and just kind of get a high-level view of whenever slave lag jumps, to be a non-zero value. And likewise, we also plot show master status, so we can look at the master file, the master position information. And what's really cool about this one is you can see if your bin logs are rolling very quickly, because you'll see something like this, where'd it go? Whoops. This tiny delta right here where my mouse is. I don't know if you guys can see my mouse. But normally you got a nice smooth pattern. Periodically there might be a small step function here. Now this one's kind of small, but when you have pretty large scale issues, you'll see that you don't have a perfectly linear line for your positions rolling, and that could indicate you have a lot of heavy writes coming through your server or something like that, which usually correlates to slaves driving up on their replication lag. And the last one I have here was, again, this is something that my coworker Gavin has been putting together, and I just wanted to show this to kind of drive home the point of, while we're talking about doing all these dashboards and things that make a good dashboard for live site triaging and watching things, it's also good to take a step back and do month-over-month and year-over-year analysis of what your system's doing. And so all of this stuff, I mean, we currently have it in Excel. We haven't automated it yet, but this pulls data from from OpenTSDB for over the past year and aggregates by month. And we can see changes in different clusters and like the actual footprint on disk that they are, what their query latency profile looks like, QPS information. And this one on the bottom right is actually QPS against the master, which is the blue, and our read-only slaves, which are the red. So you can see somewhere a couple months ago we had a significant amount of traffic got pumped over to the slaves when we had a traffic increase. And I think that's all I got for showing. So let's pull that out. All right.
I got a few. So I definitely want to second and third the query response time metrics from Percona in 5.5 and 5.6. Those are absolutely wonderful for track. Getting a fun, historically, everybody who's been a DBA has always heard has the few developers who go, something is slow. What's slow? I don't know what's slow. And you can, it generally begins this deep dive into what is a lot of cases something else. Sure, MySQL does some fun things sometimes, but a lot of times it's something else, right? It's in the application layer. The query response time metric, because it's so nice and in MySQL, is a great way for showing big upticks in query latency, agnostic of perhaps what could be other RPCs going out or other services being activated or causing lag. So I'm a big fan of the query response time metric. And then the next one on the second is definitely the table stats for rows changed and rows read. One of my favorite graphs to make is the top 10 most read and written tables on a database using those table stat metrics. That's very easy to do in Graphite, just use current highest and whatnot. And that's really indicative of sudden changes in application profiles. You're moving along, and all of a sudden you have this huge spike on one table, and you see, and then you see, oh, look, somebody must have changed something, or a query index must have changed somehow, or query changed, new query came in. I love that one. One of the ones that I haven't heard a lot of people talk about yet, or maybe I missed it, was the actual hardware. It's very great for a heads-up display to be showing CPU idle. You should be showing some of the stuff from VMstat, swap in, swap out, pages in, pages out. All that stuff is very useful. And of course at the I/O level, because that is always our problem. And so some of the things I do like to find in the I/O level, of course, %util I think is pretty handy. It's not an exact science, but it's pretty handy to see something. When it's not an exact science, it usually indicates some other hardware problem. So it's still useful as a litmus test of failure. And then there's always hardware-specific ones as well. If you're using high-end Fusion IOs, Viridents, other specialized storage, they're going to have a whole slew of fun SNMP and proc outputs that you should grab, especially heat and thermal-related errors. Everyone should be measuring those for your high-end storage.
Yes.
For your non-high-end storage, you should be measuring your smart error occurrences, because just because it hasn't errored enough to trip your hardware, your RAID controller saying it's a bad drive doesn't mean it's not a bad drive. And take this all with a grain of salt. I wish I could dive deeper into it. I probably should have prepared some time. And that's hardware. And of course, networking, as we mentioned last week. Since SSDs, flash is getting huge, I'm starting to see more really hard-hit databases because they're no longer being totally saturated by the I/O before they saturate what is usually a 1 gig network. And not everybody's just going straight to 10 gig yet. So it's expensive, and it's not what from my experience in companies, it's not normally what's laid down as the default. And with SS Flash, and you're way able to saturate that in MySQL. So that's hardware. Some of the other MySQL specifics that I don't think were mentioned, history list length. I love measuring history list length because it's a great indicator of someone jamming some enormous transaction through. And that's always a good indicator. One of the other things, lock weights in InnoDB, I usually do measure that. And then of mutexes as well. Although mutexes can be difficult to measure, and I don't have a lot of experience with performance schema, so I'll leave that to someone else to explain how to get it. But show mutexes previously. Taking a sampling of that occasionally, especially under high load, can show some interesting bottlenecks in MySQL, which usually can be resolved with various tweaks to the CNF, such as changing how many buffer pools you allocate or your adaptive hash index. And I think that's what I got as my favorites. Hardware for sure. Measure every single bit of your hardware because it's going to show you right off the bat if you're bottlenecking at the hardware layer, and you should be examining that first. It's a great indicator for heads up display.
Yeah, and I actually just want to chime in for what you said, John. So one of the things I forgot to mention, so I did a presentation at Percona 2 years ago, just talking about how we monitor MySQL with OpenTSDB. And so all those metrics, like history list and the various status counters, we actually just have a dummy collector that's structured in this way. I don't know if you guys can see the shell script that well, but show global status and then just export all those as metrics to be put into TSDB. And so yeah, we just have the collection of all that information for free, and then we can look at it. And so one of the dashboards I wasn't able to show because I couldn't get it all cleaned up before this was all of those OS level metrics you were talking about. Fusion IO metrics are actually the scary one that we weren't monitoring until about a year ago, and that gave us some very interesting insights into things happening. But yeah, InnoDB history list length was a very powerful one, and one that we've started looking at more recently is I think it was the InnoDB checkpoint target age.
Yes.
Okay, you've heard about this.
Yeah.
So we had a problem where replication would fall behind on a slave periodically and just would never catch up. And what we discovered is that I think there's a bug that I can dig up the bug report for, where the checkpoint target age was a feature that was put into Percona to help prevent the server from stalling if it fell behind on checkpointing and the purge thread. And so what they did was they made it so it kind of rate limited checkpointing and incoming query execution so that it could let that purge thread catch up. But the problem that we had with that is it also limited the replication thread. And so if you're on a downstream replica that its only job is to replicate and it's maybe not even serving reads, it would just kind of get stuck in this weird state where it could never catch up or would keep falling behind for a long time. And so that was another metric, InnoDB checkpoint target age, that we started looking at a lot recently. And we found if you set the checkpoint target age down, cause a stall on the server for a couple seconds, couple minutes, and then put it back to normal, suddenly replication would just catch up really quickly.
Yeah, I definitely have seen that one. That one, yeah, that's definitely another one. And that's one of those weird things where, like, you don't know about it unless you actually have someone looking at it. And you understand what that means, too, because it's a little weird, too. And two more of those to match you is binlog cache disk usage and sort and passes. Those are the two other metrics that I found. They're super easy to fix, and they cause unwanted I/O. And so binlog cache disk usage, so of course just up your binlog cache because it's cheap for the most part. And sort merge passes for your sort buffer, real easy to check on and real easy to graph, and really you should be able to keep them at 0 most of the time, assuming you're doing small OLTP. Yeah, and then checkpoint age, and I usually graph the actual dirty pages. I graph that as well on it because it's nice. What you can usually see is you get this nice like line going across the graph. I wish I had a picture of my hand. Right there we go. So you got this hand, and then you've got this nice little spiky thing kind of going on, and then all of a sudden it goes, and you go, oh, that's where my database stalled. Maybe I should work on this a little bit. And that one's fun. There was a Percona document describing in detail how to both measure that and manipulate it for better effect. You're probably doing a better job than I am. So I'll see if I can find that and throw that in the doc somewhere.
Cool.
I think that I didn't hear anyone talking about the com counters. I agree
you got us, Jerry.
I agree with everything that was said this far, and I even have that set up on my desktop just for fun. But the one I like to use because it's an early warning system is the com counters. On a business, usually what you see is that time over time, the com counters kind of increase with the volume of business or with the application evolution. But whether you have spikes or you have valleys, usually those are indications that something is going on in the system. And at that point, I like to switch to the other charts to see what might be going on. So if you have an I/O stall or you have mutex contention or your history, your undo history is huge and needs to be purged and things like that, all of these things are reflected in variations in the com counters.
Yeah, and that's a good point, Jerry. And something, Jeremy actually had a snippet showing one of the graphs they watch are the command counters, but something that is kind of forgotten is, what are you actually looking for there? Because it sure changes in them, maybe you expect them or not. But one of the other things is, if you have a slave that starts falling behind on replication, check to see if your master has a lot more updates, inserts, deletes happening, because that would explain saturation of things in your binary log.
Correct. They're basically flags to something else. They're the portal to the diagnosis.
So actually, Ike, how about you? What kind of graphs do you watch to gauge the health of your system?
Yeah, to be honest, we don't do a lot of MySQL specific graphs. It's more sort of end user stuff of tracking ad impressions and other ad events. And then when we see anomalies there, then we'll dig into some of the MySQL data we have in Munit and New Relic and things like that. But in terms of actual MySQL dashboards, we don't do any of that. So I'm definitely on here just to learn what you guys are doing and come up with some good proactive things I can do.
Yeah, and I mean, definitely, I'm sure a lot of us would be willing to share what we've already got set up and what we're collecting. But like I said, the simplest one is just, if you're not already, start dumping show global status periodically and writing that into some sort of system that you can use for tracking metrics over time, whether it's Ganglia, OpenTSDB, Cacti, or something else. And And let me see, who else we got here? And actually, yeah, Mark and Morgan, I'd like to hear from you guys. What kind of thing? Is there anything that we missed that maybe could have a secret gotcha we're missing, or is there some other like monitoring solutions or other things we could watch?
I might comment quick because Mark has all the value to add to the conversation. He's the product guy for the monitoring tool at MySQL. The only real thing that I was thinking of is that I love Brennan and Greg's sort of let's call them philosophies or ways of which to diagnose problems. So if you're just looking from a high level, one method he suggests is the use method, utilization, saturation, and errors. And I like some of those tools mentioned to do that. I won't go over them already, but I like the rows red counters that a couple of people mentioned. Just for if someone says this is something wrong with the database, it's almost the first one I look to because I want to see if anything's changed. And then I see if my workload's changed, then I can investigate more. But if it's the same as always, then I'll see what else has changed in some other area. Anyway, that's my top number for heads-up display.
Actually, you mentioned the rows return. The other one that it's interesting are the handler counters.
Right, but handler is just sort of like at the storage engine MySQL to InnoDB. I like rows red from InnoDB. That bottom line of show engine InnoDB status, because that to me is like it's one of the best numbers for just getting a raw throughput number from InnoDB. I mean, you can't tell with that if it's logical or physical, so it's not perfect. But that's one of my for workloads I've managed most accurate numbers that I've seen for measuring throughput.
I think you actually want to do both. You want to do the InnoDB rows red and the handler.
You look at both?
Wow, right? Because the handler variables are literally all of the rows that are interacted with off the SQL layer and the storage engine, right? And there's a couple in there, the handler read ran next and handler read ran, which are full scan identifiers. If those are increasing, then you're doing a full scan for a table. And the rest are either point lookup type things or how many rows have been committed versus updated versus deleted, all of that kind of stuff. You should really track all of them. They're all useful. The other one that I didn't hear anybody mention was something like temp tables versus temp tables to disk as well.
That one, yeah, there's one we totally missed.
Yeah. Monitoring both those. Trying to keep your temp tables to disk as low as possible. That's probably a good thing to go for. Likewise, with other things like the thread cache and the table cache, you can monitor connections versus threads created, or the number of table opens versus opened as well. They're just good identifiers for. On the thread cache side, it's just good performance to always have threads spare to get your connections right. On the table cache, you can often see that change if the schema changes or something like that changes over time. Those are probably the ones that I think you guys didn't mention that are major ones. The rest, I totally agree with. I mean, we create this. Well, my team creates this monitoring tool called Enterprise Monitor. And we pretty much graph everything that you guys talked about apart from the hardware stuff, like the temp sensors for Fusion IO and all of those kind of things. Otherwise, we're collecting pretty much all of it, including looking at CPU and memory and stuff side by side as well. I mean, seeing all of that stuff side by side and stacked up, as many metrics as possible, has a huge amount of value because you can correlate the spikes all the way down the stack of all of them.
Does Enterprise Monitor automatically kind of evaluate the data that's collecting and make suggestions, or make suggestions on things that you can change, or bubble them up somehow so it's easy to see that there's a problem?
Yeah, so it's architected to both alert and graph on the same data. So where a lot of these tools have one system to actually do checks for alerting like Nagios and another one like whatever it might be, Graphite or OpenTSDB or whatever it is for alert or instruments. Ours actually just all works on the same data. So we actually do checks in the background. The data flows across what's called the advisory infrastructure. Checks are done on all of that and events raised if we find things. There are checks that do things like compute the trend of disk usage and tell me when it's going to run out in 3 months' time versus 2 weeks' time or whatever it might be. And then as the data flows out with the advisors, it then goes into this instrument. So they actually graph the actual data that things were alerted upon. So you don't have this disjoint set of two things saying something happened at one time versus another time. Trying to track those things down. So yeah, I mean, it's got probably about 140 different advisor type checks that do various different things. I don't know how many graphs now. There's probably over 100.
So something that I'm also more interested in is in Enterprise Monitor, do you have kind of like a canned dashboard that you present for any given system, or does it kind of, is it up to the user to figure it out? Because I think that's kind of the problem that a lot of us have when we set up our own monitoring systems or plug in MySQL graphing with our existing monitoring systems, is trying to figure out what, this is the list of things that you should probably watch, but then it's a matter of like, okay, so you have like 100 things you're going to watch. Which ones do you put at the top? Which ones do you start with for the drill down process?
Yeah, so I mean, when you drill into either like a group or a single server in MEM, the default dashboard is a pretty simple one. It's got like an availability stat at the top. And then it's got 3 graphs down underneath it. The first one is concurrency metrics, so how many threads are connected, how many are currently running. The second one is like a throughput metric, which is monitoring all the counters, the major ones for DNL and select. And the third one is a query response time index, which is kind of like, have you guys heard of AppDex? It's like a metric that covers user satisfaction from the application perspective. You set a threshold, an ideal threshold against query response times, and then as it degrades away from that, it goes into these different bands, basically. So we use the performance schema data from the digest table to see the response times, and then we base this AppDex index off the average or the average response times across the board.
I'm sure a lot of people use New Relic. Mark, they use the same scoring system.
AppDex New Relic does have an AppDex thing. But a number of monitoring tools have started to use AppDex type statistics. They're just like a high-level indicator of user satisfaction, essentially. So we choose those as the top 3. I mean, they're the things that we put on the main dashboard, along with a list of the highest level events that we've detected in the background as well. And then when we drill into a certain, or if we want to drill into statistics, then we just have a graph dashboard page that lists every single one of the graphs at the moment, rather than drilling into specific areas. Although we've just released the Enterprise Manager plugin as well, and that does have specific performance pages in it, so it drills into things like the InnoDB buffer and its statistics, table activity, and just the statistics around that, connection activity, like network usage and all of those kind of things. So yeah, I guess we've got 2 different tools that try to do both ways of doing things at the moment.
Cool. So Jeremy was actually asking Mark if there was if you could like just show the dashboards that are on there real quick. I don't know if you have a demo instance up or not that you could do quickly.
Or if you have screenshots.
That'll work too.
And if you need 2 minutes to do that, we could probably chat in the meantime. What I was going to say is it's interesting how you interpret metrics. I saw in the chat someone mentioned 99th or 95th percentile. Aptex kind of solves a similar problem, where it tries to not take an average and give a sort of quality score where you get a point if you meet the user's expectation, you get a quarter of a point if you're within 4 times of that, and then your total score is something less than 1, where 1 would be if you met every possible value. I really like Aptex. I find it easier to read than a 95th percentile. And businesses should kind of rally around setting a goal for certain tasks to happen. Like ads should serve in 50 milliseconds. And actually, 95th percentile is pretty bad as well. It means that 1 user out of 20, you're basically saying, sorry, no suit for you.
Yeah, and I was going to say, like, 99th percentile is even a more valuable one to watch because you get even closer, right? You know, and if you can get to the 99.9, you know, however deep you want to go. And there was actually something that I found interesting, you know, because with MySQL we have you have a lot of command counters that you can use to do things, and then we have to build some sort of system in front of it that will aggregate that information over time, typically. One of the things I've noticed with just setting up monitoring for other systems like HBase and HDFS, their metrics system that is collecting all the counters all the time and whatnot, they also have some auto aggregation you know, up towards those percentiles in some of their metrics frameworks. And that might be maybe something the curious thought of. Like I think Performance Schema might be collecting some of this. Mark, you can correct me if I'm wrong there. But you know, being able to auto aggregate the 95th and 99th percentile over time as new data is collected inside of the server itself.
Performance Schema doesn't do anything like that at the moment. Actually, I had a chat with Aaron Schwartz while I was out in at Open World this year, and he was after histograms in that data, and it's something that we've been thinking about for a while as well, because with the queries themselves, sometimes the response time of them can be very wildly as well. And one of the things that you want to see is when looking at these response time metrics is a proper histogram, and a proper histogram over time, right? So I mean, and we don't have that ourselves yet, but it's something that we want to do. Where you can show something like a heat map of the response time over time, too, and that would be a good indicator of the different kinds of queries and their response times, pretty in a really nice succinct graph. And somebody mentioned, was it you, Morgan, the Brendan Gregg way of monitoring, right? The way that he monitors I/O and all of those kind of things are generally in heat maps with some kind of histogram as well. So those are the kind of things that are interesting to me at the moment in trying to get those kind of statistics.
Sorry, yeah, just catching up on chat with a few people since Shlomi just popped in. And yeah, Shlomi, just what I told you in chat, we're talking about what makes a good dashboard, and a few of us have talked about, you know, all the metrics at a high level we watch. And oh yeah, I mean, if you want, I'll give you a second to look through the document of some of the stuff we've talked about, or if you want to just chime in, is there any special metric, you know, that you think most people don't watch that you do, or something like that?
We're watching table size growth over time. We also watch for the count of you know, top DML queries on the master. So inserts, deletes, updates. We have graphs for that as well. So if a certain query suddenly, you know, starts bumping, we know about that. That's another thing we look for. We also look at, you know, the number of long-running queries, the number of idle transactions, stuff like that. That is kind of the metadata over what's going on. Yeah, that's off the top of my head.
Those are pretty interesting ones. I remember we set up a long transaction like metric just to, I think it would query the InnoDB transaction table or something like that, and look at the age of them. And would report if any of them were over, I think, 10 minutes or something like that. But I mean, have you found that you've needed to use that when triaging something, or?
Yeah, we kind of mostly monitor that. I do recall one specific occasion where it came in handy. Um, yeah, but I think it's a good metric to watch over. Most of the time, we don't really, catch the evil guy because of that.
Got it. Okay. Do folks have anything else they want to add around monitoring and metrics? Mark, you said you had an app server starting up still.
Yeah.
Did we give you enough time, Mark?
What I wanted to point out is, we are showing Ganglia, and you have Cacti and Enterprise Monitor, and a bunch of other Graphite, which are usually complex systems. But if you have one or two servers, you can still monitor all these things using CollectD. And I used to have a presentation that I gave a couple of years ago, and I use it for my own VMs when I test things. It's called Poor Man Monitoring, and you can use LightD, CollectD, and there's an RRD charting software library, and you can do all this in under 1 gigabyte. So small servers, you don't have a high overhead, but you still are able to create all these charts and dashboards without the overhead of having to install a Cacti server or Ganglia or Zabbix or my Enterprise Monitor. I might have to dig that out.
Yeah, if you can give me a link to that, Jerry, that actually sounds kind of interesting. All right. Well, we got about 20 minutes left. So, Mark, if you want, you can we could jump over to talking about MySQL SYS a little bit.
Yeah. So the idea with the SYS thing, I don't know if many of you guys have seen it or used it. I know some of you have. I've talked to some of you about it. What I'm kind of interested in hearing is the things that you guys wish was in a schema like SYS, right? Is there certain helper procedures or views or functions or whatever they might be that you think would be worth going into SYS by default? And I'll give an example. One of the things that I'm thinking about at the moment, one of the top things on my blog when I look at the hit stats is a blog I wrote about killing long-running transactions with events, actually in the server. So just looking for any transactions that go over a certain amount of time and killing those off. And I'm thinking of putting something like that into SYS as well, and I'm just trying to gauge feedback on whether you guys think things like that would be useful. Any other things that you wish were in the database by default? That's really one of the discussion I wanted to kick off rather than do a demo, right? Unless you guys think you need to see a demo of it because you know what I'm talking about.
So something that can find and kill off large or long-running transactions is definitely very valuable. I mean, we ended up writing our own tool in Perl that does just this. It just kind of runs on cron every, I think, 5 minutes or something, and looks at the history list. If the history list is over some threshold, which I think we set to 5 or 10 million, then we'll go and find the long transaction on the server and just kill that off, and we'll try to collect information about it first. And I think that's one of the more valuable ones is having visibility into, yes, are there long transactions on the system? If there are, with 5.6, I think you can get the last query that was executed by a given connection. So getting that information so that we can get some stack trace or debug from our application potentially, and then killing it. And one of the other things we have our tool do is send us an email anytime it does it, or something, some other follow-up action so that you can be notified that it had done that, and here's the data that was collected about it. But yeah, I'm not 100% sure of all the other things that are in SYS right now because I haven't used it yet, unfortunately. But a transaction monitoring killing thing definitely sounds really valuable to me.
Mark, could you real quick just give a general overview of us of what SYS, like a collection of views, much kind of like what Shlomi has with his with common schema and some of his tools, not necessarily the script, but the tools in there.
And
kind of like that.
describe the relationship with performance schema. I think that's helpful as well.
Yeah, so I mean, at least at the moment, there are a bunch of views that are in there. It's kind of like common schema and Shlomi's stuff, but they're very. I see the common schema and SYS at the moment, at least, as not overlapping in many ways, right? They tend to focus on different things. So common schema tends to focus at the moment on administering things like grants, looking at information schema data and all of that kind of stuff, whereas SYS instead largely focuses on performance schema data, so underlying data like statement. Let me just share a damn screen and show you something.
So if there's like one procedure review in there you think that is like so awesome and so useful to you that it should be merged into core immediately, like what would that be out of MySQL SYS?
Yeah, give me a sec.
Sure.
Can you guys see my screen?
Yep.
So there's like, at the moment there's 90 different views by default. Does that look okay to you guys? Can you see it all right?
I can read it.
Okay. So there's 90 different views, but that's kind of a funky count. These $X ones are actually raw views, so they expose the raw statistics in various different ways. And then usually they've got a counterpart which is not an $X one. So these are the ones that you can just use through a client versus the $X ones which you're supposed to use through a tool to capture over time, for example. Because these ones all do formatting of the underlying data, right? So in performance schema, it tracks everything down to picosecond precision. When you start looking at big numbers for time with picosecond precision, it's really hard to look at it. Same with bytes and things like that. So what these do is they package up these general use cases that a lot of different people have around the performance schema data. So I mean, the first one I think is this statement analysis one, which works on the statement digest data. So commit comes up at the top. Let's get some interesting ones in there. So it's a digest by the normalized statement, so all the literals are stripped. It then tells you how many times it's been executed, its latency stats, its row statistics, whether it creates temp tables and all of those kind of things, sort merge passes, all the things that we're talking about monitoring at a global layer. You can drill into that down to the per query specific layer, right? So where you're looking at these stats over time on a graph, you can immediately then actually go and snapshot this table and see exactly which statements are causing those things. That came in 5.6, and it's been amazing for people to actually understand. I mean, we built Query Analyzer, which has this kind of profile, and this was modeled on Query Analyzer just because of the usefulness it had to all of our customers, right? It's like a slow query log digest, but just directly in the server with no slow query log. And then there's other things like you were talking about monitoring table statistics. So we've got something very similar in performance schema now that tracks both table and indexed stats. Show you what that's like. It's on a per table basis, the total latency against the table, how many rows are fetched and inserted, and actually breaking down the I/O per table as well from the other file I/O data that we've got. So you can track all of those kind of things over time. There's a lot of things like that. I mean, just looking at the table names rather than show you them all. We summarize things by host. We look at buffer stats so we can tell how much of a table is in the buffer, for example, those kind of things. File I/O by the files themselves. This is 5.7 stuff, so this is, I'll show you an example of that. This is memory usage throughout the server, but they're broken down by the threads. So the main thread has InnoDB allocated. This thread is my connection and is using 1.5 meg and that kind of stuff. But we also do that globally and again broken down by user and host. So I mean, there's a lot of statistics in there, right? I mean, breaking it down with the user summaries, the actual weights, which are things like mutexes and all of that kind of stuff. So whilst
I have some thoughts actually, Mark.
Okay.
Just so, now that we have a quick background of some of the stuff that's already in there. So the big one is the query information, right? The whole reason you have the server is to answer questions. And so you have the stuff that you get in 5.6 and 5.7 performance schema, and prior versions through stuff like PT Query Digest, where you can see total execution time spent by a certain fingerprint of a query and things like that. Something that I've actually been really vying for, though, is it possible to get CPU and even I/O and memory information tied to a given query type that comes through the server? I don't know if the data is there or available yet, and if not, maybe that's something future additions to performance schema, but I think that would be a really nice one, is being able to say, CPU is high on my server, is there a particular query that is causing that I could drill down and find?
Yeah, I mean, it's you can't get certain things like that. Well, I mean, you can't get all of it, for that matter, at the moment. For example, when we trace statement statistics, we can trace down all of the different file I/O that happens on the thread that we're on, but there are certain things that are just done on different threads, right? When you execute a query to InnoDB and you want to read some data, a lot of the time it's going to go off to some async I/O thread that's actually doing the file I/O and then passing it back up through the buffer pool. So I mean, there's quite a bit that is quite hard to trace through the entire stack to then equate back to a query.
Maybe if I can paraphrase you, Mark, the accounting is hard, particularly in an engine like InnoDB where things might be merged and shared in the background. How do you attribute to one particular user?
Or one particular query as well. And it is very hard. Now that being said, there are underlying weight events that are all tracked underneath a statement, and it wouldn't be hard. Well, I'm not going to say it wouldn't be hard. It wouldn't be a long shot for us to actually start accounting some more of the sum of those kind of weights at the higher level, at the statement level. I've talked about that with Mark, the principal developer on PS before. Because those are, being able to track file I/O back to a specific statement, or a higher wait time on some event to some class of event. It wouldn't be every event.
Yeah, because the thing I was just imagining was, just from what I can remember, but when working in Oracle, was you could run an automated workload report or something like that. Yeah. And it would, similar thing. It gets fingerprints of queries and assigns, estimates of CPU and I/O utilization to them, and based on that, then you would sort by those, and you could figure out, if I have a CPU problem on my server, let me focus on the queries that are saturating my CPU, and vice versa. I mean, currently for us, when we're and this is definitely a hardship we have right now, even just using the anemometer with data from Query Digest, is what is contributing all that CPU usage? Is it sorts? Is it is it specifically expensive like file sort kind of things? Is it just locking and a lot of lock timeouts, or not lock timeouts, but like just a lock sum total, or some other things? And so I think that's actually like the next huge thing that could be tackled, is if you could easily have a view where you could sort by top CPU users, top I/O users, and potentially top memory users. I don't know how useful memory would be, but I could see a case for it. And then, maybe a further breakdown, which I think this information might already be available, but also looking at users, and is a particular user contributing a lot of CPU usage or I/O usage? Because then you could also, if people are being disciplined enough about using accounts for different applications, then you can easily track it down to that as well. And having a simple view to pull that up would just be absolutely golden.
So
I would also
was going to show an example
like
there.
to chime in.
I've got one of the broken queries that I've been fixing for 5.7 and their group bys. Whoops. Go for it, Swami. I'm going to stop sharing. Yes.
Okay. Yeah, I'm sorry. I wanted to chime in before time runs out. And you know me, I always like to tell a story. So I absolutely agree. Common schema is more about operational stuff, information schema and stuff like that. And performance schema is on. And sorry, sys schema is on performance stuff. I'm going to say something that will begin to sound as a criticism, but is actually a form of advice, right? So it's funny that you mentioned killing idle transactions, because, for example, you might find that as a one-liner in common schema, there's a view that gives you all the idle transactions, and one of the columns from the view is the kill statement for that, and you can wrap it all with eval, and there it goes. Similarly, I see there's a new tool in MySQL utilities which gives you the grants per an object type, which is also something that's been in common schema for 3 years now. And so this is not about criticism. Why am I telling that? Because I find it time and again that people are completely unaware of stuff that's already existing in common schema for years by now. And what I would like to, my advice to you, Mark, is not to overwhelm the sys schema with dozens and dozens and dozens of views, because I think what's overwhelming about performance schema is the fact that there's dozens and dozens and dozens and dozens of views, and nobody knows where to start with. And I think what was very good with PS Helper at 5.5 is that you had those 7 or 8 views which just gave you where do I spend most of the time on? Where do I spend most of the CPU on? And I think this must be the highlight for the sys schema, for it to be accessible, and people say, okay, I just want, give me a 30,000 feet overview, tell me where the time is spent on the I/O, the logs, the whatever. Then you can drill on furthermore. But if anything, I suggest that this must be the focus. Just aggregate as much as you can, and operational stuff like stored routines that kill idle transactions. I think this should come on later. But these most aggregated, most commonly used views, etc., they must be pushed and highlighted, because when I browse through the list you just presented, it's scary again. It's as scary as performance schema, and I'm not saying this is a criticism. Obviously not. Great job on sys schema. It's wonderful. I've used PS Helper, and it actually solved one huge problem we had for months. So great work, but I'm afraid it's going to be bloated again. And if there's any way to categorize, or most people, you want these 7 or 8 views, and the rest of you guys might want to look at those, because that's what I see is happening with common schema. People, they don't know anymore what's in there. There's dozens and dozens of stuff, and people just don't get to read everything. So that's my little piece.
I think that's a good point. I'm not sure how to tackle it, because there is a bunch in there based on these different use cases, and as more gets added, like memory and stuff like that, just adding to the list, right? I mean, and replication stuff is going in there. It's hard, because the amount of stuff that's actually coming in performance schema is in many ways forcing the amount of things that go into sys as well, because it's just trying to make each one of those specific areas easier to interact with from a user perspective, right?
A suggestion that I actually have on that, because I have to agree with Shlomi, that it could get a little bloated. But I mean, looking at them, like it looked like there was good hierarchy around the breakdown of things. And so maybe an easy way without getting it too out of control is having a certain view prefix, something as simple as like quick start underscore something, and that just implies like there's only 5 or 10 of those, and that's your 30,000 foot view. And then everything else is there because you need it. You know, everyone's got a different workload. You know, it's like John was talking about I/O being a huge pain for them earlier, and that's one of the metrics they watch a lot. My team, I think I can count on one hand how often we look at I/O because we run so much solid state that it's actually CPU is our problem more often than I/O. But having the 30,000 foot view of everything and maybe just a common prefix that you know this is where you start and then drill down might be the easiest way to get at it, I think.
Jeff, wouldn't that be the role for things like MySQL Workbench, though? Because this is really a raw interface to wrap around performance schema, and the visualization for product usability comes with those tools that would sit on top of this. As, for example, performance schema data, I think they call it the performance dashboard, it's the official name in Workbench 6.0 and above, does use SYS as an underlying project.
So that's totally possible. I mean, personally, and maybe that's something that will change over time, but like, opening a graphical tool is not my first gut when I set up a system. Personally, I would rather just see what's in there and what's available. But if that becomes the prescribed method, and maybe things will change over time to that's totally valuable, I think, too.
I think also it's also, I mean, not directly because people aren't paid to do this, but obviously just the thought leaders in the community, Percona, Shlomi, Morgan, Jeff, all of you guys, you're pretty much all of everybody here. So like, it's kind of the responsibility of these people to blog about this stuff like that. It's not necessarily like all this stuff should be available, right? It's not like you can really boil it down to just the useful stuff because it's all useful with all respect depending on the workload. So it really is the responsibility of people like who write the blogs, who find the interesting stuff, who run the panels, to go out there and be like, hey guys, I have this problem and it used to be hard and now it's not. Let me show you how using this new tool called MySQL SYS. And a lot of that ends up really getting disseminated out into the community. Common schema, for example, is immensely useful. And I don't feel it has the community penetration it should, considering how easy it is. So, like, everyone writes for loops to kill queries of a certain class. Everyone does it regularly. Common schema makes it easier. Why not? Right? So part of that is getting it out there, getting it on the blog rolls, and talking, you know, of course, people should have the responsibility to watch our fantastic show all the time. They really should be. So, and maybe more people should know about DB Hangouts, and we should push it harder. That people should be watching this regularly for good content. What we need to do to make that happen. So yeah, I mean, like I think if like 3 of us here wrote a good blog post about something fun and useful we found in MySQL SYS that makes it infinitely useful and got it on Planet MySQL, I think you'd see the uptick go better. Not only that, you'd start getting more feedback from people who say, well, it kind of worked for me, but not really because I'm missing X, right? And of course, you'd also get 10,000 people asking you completely irrelevant questions in the comments, right?
So actually, I guess because we're kind of tight on time now, but Mark, you know, ultimate takeaway: MySQL SYS works on 5.6 and up. Is that correct?
Yep.
Okay, so if you're running 5.6 and if you're not, start getting there. It will change your life.
I think it does. I mean, the amount of data that I can get out of it, I mean, it's changed the way that we tune our database interaction with the mem app server in a huge way. Right, so I mean, not just showing it off from the perspective of, okay, we've got this stuff and we can use it, just it's helped our team do tuning as well, just by spotting all of these different hotspots from it. So, yeah, if you're not on 5.6, you're crazy.
But yeah, so I think that's kind of the ultimate takeaway is if you're not on 5.6, get there and start using these tools. Like, start trying them out more, start experimenting and seeing what's available. I think something that Morgan had mentioned in 5.7, the memory instrumentation and transaction and prepared statement stuff was added. So that's not available in 5.6, but just some of the other metrics that are, and you know, specifically just the query digest stuff in your server is already there. I know for us, Anemometer is already built to support pulling that information out of performance schema and possibly SYS. So that's even something you could start using too, instead of having to have a janky cron job that runs PT Query Digest every now and then or something. And I mean, I know for us, just here at Box, I mean, we're in the process of a 5.6 upgrade, and once we get it out completely wrapped up, this is definitely a lot of the stuff we're going to start looking at again. So, yeah, I guess I would just say homework for everybody. Get upgraded, and then start using the tools.
And then write about it. And tell people to watch this awesome show called DB Hangout, which you can find at the Twitter link of @DB Hangouts.
Okay. All right. Well, we're out of time now. We're over time, so I'm going to start wrapping this up. Any last questions or comments about MySQL SYS? Okay. All right. Well, we'll see everybody next time. I've got some topics for next time, so I'll have a blog post up about those probably in a week or two.
Do you think next time, real quick, do you think next time, Shlomi, would you have a chance, or I'll even demo it if you want to, but the offer's kind of here. Would you mind giving a show off of Orchestrator again, which is probably going to be one of the most useful tools in the MySQL ecosystem if you keep expanding it the way you do, especially with the new engine?
Absolutely, and I'll be happy to, and there's some new stuff on the pipeline as well, so I can talk about that as well.
Cool. I might ping you after this to chat about that, because I've actually got something I'd like to show off as well. So.
Okay, cool. I will add that down. Alrighty. Beyond that, see everybody in 2 weeks. Have a good time.
Hey guys.
Bye-bye.
See you. Bye-bye.